Welcome to my project. Our project is Advanced Driver Assistance System for Driver Drowsiness Detection using Deep Learning Module. Myself Gopi. My team members are Harshini, Gayatri. Our project is supervised by Divya Sundari ma'am. Our basic agenda is abstract, objective, introduction, literature review, design and methodologies, standards and policies used, implementation, testing, input and output, include demo video, conclusion, future enhancements, web reference link, references, plagiarism report of PPT, poster presentation. Abstract. Nowadays, most of the accidents was caused by human errors, which can be avoided with drowsiness detection system. The purpose of the drowsiness detection system is to prevent of accidents. The system will detect the early symptoms of drowsiness and warn the driver through an alarm system. Drowsiness of a driver are the main cause of road accidents. In this project, the module of ADAS is represented to reduce the number of accidents due to driver drowsiness and increase the transport security. The system acts with an automatic driver drowsiness system based on visual information and artificial intelligence.
The main of this project is to detect the drowsiness of the driver using deep learning approach to avoid the road accidents while the driver in drowsiness. Scope of the project. The main focuses will be based on the concept of drowsiness detection system to avoid the road accidents while the driver is in drowsiness. We use Python language, TensorFlow, OpenCV platforms to implement this project. Introduction. ADAS or systems intended to help the driver in his driving activities. Almost all vehicles accidents are caused by human error, which can be avoided with advanced driver assistance system. The role of ADAS is to prevent deaths and injuries by reducing the number of car accidents and the serious impact of those that cannot be avoided. There are numerous techniques to detect drowsiness. In this project, we put forward a deep learning based approach to detect drowsiness of the drivers. We have used a neural networks, which is a class of deep learning. We used the face and eye regions for detecting drowsiness. We mounted a camera on the vehicle, will will record on frontal images of the driver, which will be analyzed by using AI techniques such as deep learning to detect whether the driver is drowsy or not. By using this information, the system will be able to alert the driver and prevent the accidents. This is the literature review. Module 1, we collect the dataset. First, we have installed a Spider software in our laptops. As a Spider as a main administration install, we install the OpenCV TensorFlow Jupyter softwares. We have installed Spider Promet and installed all the required softwares. In order to execute the code, we click on continue to be running. For running in TensorFlow, we have clicked Shift plus Enter. We have downloaded the MRL datasets from the Google. We have extracted 37 images from dataset. We have two types of images, closed eyes and open eyes. There are 37,000 images are there in dataset. Now implement the code for the working of the module. In second module, we detect the face. There are many famous classifiers for deep learnings like ModelNet, AlexNet, and GoogleNet. We take a image as an input from the camera with the help of webcam. We take images as an input and access the webcam. To detect the face in the image, we need first convert the image into grayscale as OpenCV algorithm for object detection. It converts a color image into gray images which we used in the input. We need to extract only the eye data from the full image. The score is basically a value we will use to determine how long the person has closed his eyes. So if both eyes are closed, we'll keep on increasing the score. And when eyes are open, we decrease the score. These are the standards and policies.
And these are implementations. In this implementation, architecture diagram, user case diagram, and data flow diagram, ER diagram, collaboration diagram, sequence diagram. In this architecture diagram is a visual representative that shows how components of a software system in depicts the overall structure of a software system. If the driver closes his eyes and the software detects the face from the video and takes the eyes and input, and if the eyes were closed and in the input, in the alarm sound will come and wake up the driver until the driver open his eyes. In this user case diagram, it describes the high level function and scope of a system. In this, but now how systems operates initially. User camera, face recognition and wake up applications act as a actors, and remaining terms which is in the square box represents as a process. In use case diagram, actors will be represented as in symbols. In data flow diagram is a way of representing a flow diagram through a process of a system. In this system, no control flow, there is no detection rules, no loops. In this figure, from driver's behavior, we can predict the driver's drowsiness, and from camera, the software can be able to extract the open eye and closed eye data. And if driver closed his eyes, the software gives the alarm sound to the driver. In this sequence diagram, our system sequence diagram, the process needs to carry out a functionality. The total project will be represented in a sequence. From the process will also takes place one after another. From the sequence diagram, we can easily predict the next step. In this ER diagram, an entity relationship diagram is a graphical relationship that depicts the relationship. In this OpenCV, camera, TensorFlow, and driver face, and the attributes are eyes closed and eyes open. The camera will start recording and collects driver face, whether the driver eyes are closed or open. In this collaboration system, the first step is reach the input, and the second step is submit the image, and the third step is separates the image, and the fourth step is runs the image, and the fifth step is detects the eyes, and this given the output is gives the alarm.
There are five types of testing: unit testing, integration testing, functional testing, white box testing, and black box testing. In unit testing, testing is the smallest testable unit of an application. It done during the coding phases by the developers. To perform a unit testing, a developer writes a piece of code to verify the code is to be tested correct. Integration testing. A series of high order tests are run after the software has been incorporated. The major goal of the testing is procedure is to take unit tested modules and create a program structure that flows the design and specification. Functional testing. Func- Functional testing is centered one of the following items. Valid input. Identify classes of valid input must be acceptable. Invalid input. Identification of classes of invalid input must be rejected. Before functional testing is complete, additional tests are identified and the effective value of current test is determined. White box and black box testing. White box testing. It is a testing where the software tester has knowledge of inner working. It is used to test areas that cannot be reached from black that cannot be reached from black box level. Black box testing. Black box testing is a testing that software without any knowledge of the inner working structure or language of the module being tested. The test provides input and response to the output without considering how the software works. And now we will show the implementation of our code to our project. The conclusion of our project is reduce the accidents by giving an alarm sound to the driver when he is in drowsy state. The main theme of our project is detecting the driver conditions. It gives the sounds in order to bring him in active state. This is the future enhancement. Some of the web references and video links. These are the references we collected from IEEE papers. This is the poster presentation. Thank you.